So in the last video I showed you how we could use our calculator to find the solutions and the factors of our quadratics. This here in fact would be a quadratic. So I'm feeling kind of lazy today and I want to do it via the calculator. So I'm just going to go ahead and I'm going to enter that exactly how I see it in my calculator, and I'm going to go ahead and graph it. But when I graph it, I see that there's a problem. This is asking for the solution, and if you recall, the solution when I have simply one equation, I'm not talking about a system, that's different. When I have one solution, I am actually looking for the zeros, the x-intercept, or intercepts. That's where x is some value, y is 0. Okay, that's where I have some value of x that makes my y equal to 0. Okay. Oh, the one thing I forgot on the other video was also the word roots. I'm looking for the root or roots. So that's only found on the x-axis. So my quadratic is not touching the x-axis, so I'm like, oh, well, what do I do? So initially you're going to think there are no solutions. Well, you're half right. When my parabola does not touch the x-axis, that there is no x-intercept for this problem. Okay? So that means that there is no real solution. But you can't get off the hook because there has to be two imaginary. There are two imaginary solutions. Okay? There has to be. And how do I know that? Because it's a quadratic. So just a little review. Parent function f at x is equal to x squared. This square right here is telling you how many roots you have. Okay? So I'm going to use the word roots instead of zeros because my roots are imaginary. There's nothing on the x-axis. So what am I going to use? What am I going to do? I have to do math. Sorry. There's no getting around that. So I have to use the quadratic formula. So the quadratic formula is a formula that always gives me my roots. So it always gives the roots of a quadratic. It has to be a quadratic. So my quadratic formula always gives the roots of a quadratic. So this is it. It's going to be x equals, right? X, isn't that what we had in the previous example? X equaled something. That would give us our x-intercept, right? So it's x equals negative b plus or minus the square root of b squared minus 4ac, the entire thing, everything, over 2a. Now, there's some cutesy songs that can help you remember that. That is on your formula sheet. If you just keep writing it down, you remember it. I don't do cutesy songs, so if you're interested, you can look it up and learn that. You may have learned that from Algebra 1. So the key is now is I need to figure out what A, B, and C is. Okay? So that means I have to get it in ax squared plus bx plus c form. And right now, what do I have? I have 3x times x plus 1 plus 4 equals 0. So this clearly is not in the same form as that, which means I have to do some math. So I'm going to do the order of operations. I'm going to multiply first. 3x is being multiplied to everything inside of that parentheses. So that gives me 3x times x, which is 3x squared. 3x times 1, which gives me plus 3x. And then I have a plus 4 here. So now this is ax squared plus bx plus c. I'm good. So I'm going to take the time and I'm going to write down my coefficients here. So this is a, this is b, and this is c. So I'm going to take the time, I'm going to write them down like that so I don't get confused. Now I'm just going to transfer them in. Don't forget the x equals. So I'm going to copy down x equals negative b. Well, what's my b? My b is 3. Plus or minus the square root. Notice what I'm substituting in. I'm putting in parentheses. I'm doing that very, very intentionally. B is 3 minus 4ac. What is my a? My a is 3 and my c is 4. And that's all divided by 2 times my a, and my a is 3. Okay, so we don't want to just throw that whole thing in the calculator. We're going to actually do this in parts because I do not want to get any decimals or funky numbers. I haven't worked this out, so I really don't know what the number is going to look like. But what we're going to do first is we're going to do what's under the radical. Notice it says under the radical. I'm not going to take the radical, so I am not going to touch the square root button. So I'm going to go to my regular screen and I'm going to put in parentheses 3 parentheses squared minus 4 parentheses 3 parentheses 4. Okay, just like that. Okay, that's called the discriminant, is actually what I'm doing right now. And so that gives me negative 39. So that means that when I rewrite this, this is going to be negative times 3 is going to be negative 3 plus or minus the square root, and this is going to be negative 39, all divided by 2 times 3 is 6. Okay, so that's a pretty ugly number. So when we're looking here, we see I have a negative under the radical. That's a no-no. So by definition, I'm going to write this over here. You need to know this. An imaginary number, if we have the square root of negative 1, we're going to define this as I. Okay? And that's an italics I. It's a very special I. So whenever we have a negative under the radical, we can factor that out as an I. So what do I mean? Let me do this over here. Let's just look at the square root of negative 39. Okay? So if I were to factor this, that's going to be the square root of negative 1 times the square root of 39, which gives me I square root of 39. So that means then that I can replace this entire square root of negative 39 with I square root of 39. So that means now I have x is equal to negative 3 plus or minus I square root of 39, I can't simplify that, divided by 6. So if you remember, I said we have a quadratic, and our quadratic has to have 2 roots because our highest exponent is a 2. So we have to have 2 roots. You might be saying, well, wait a minute, you only have x equals something here. Well, let me explain to you what this means. This is actually 2 roots. So this is x equals negative 3. Do you see the plus minus? We're going to take the upper root, plus I square root of 39 divided by 6, or x equals negative 3, take the bottom root, minus I square root of 39, all divided by 6. So notice that that division line goes from one end of the numerator to the other on both. So those are my two roots. There is no way we can get the calculator to tell us that answer. So you have to know when and how to use the quadratic formula in order to get your roots. So these are what's called imaginary numbers. Imaginary doesn't mean pretend. Imaginary actually are real numbers, are used all the time in electronics, and without the concept of the square root of negative 1 equaling I, you would not have such a thing as your cell phone. So I just thought I'd put that out there. So now you have one more tool under your belt to help you with finding the roots of a quadratic, especially when your roots are imaginary.